set the record for warmest global temperature 3 years consecutively. 2014 was the warmest year on record until 2015, which was the warmest year on record until 2016, which was the warmest on record, and 2017 will be right up there. Now, next slide. Next. So the critics will say, well, maybe that's natural. Maybe, it's just a coincidence. But we actually looked at that. We published an article earlier this year looking at the likelihood of setting 3 consecutive global temperature records, both with and without the effect of increasing greenhouse gas concentrations due to human activity. And I could read you the abstract about the coupled model intercomparison project, phase 5, CMIT 5, the probability, 3 consecutive records, less than 0.7% in its absence. I could speak to you in science speak, or, next slide, we could just use the summary of this article provided by Discover magazine. Next. The global warming streak of 2014-2016, a snowball's chance in hell that it was natural. That's probably an accurate summary of our finding. So scientists look at this by, we can take the observations, we can take the climate models, state-of-the-art models of how the climate system works, and we can drive them with just the natural factors. Next. Volcanoes. Next. Fluctuations in solar output. And if those were the factors that were driving the climate should have actually cooled over the latter half of the last century. It is only when we add, next, the effect of human activity, next, fossil fuel burning, that we're able to explain the observed warming. And that's the sort of evidence that has led, next, the IPCC, Intergovernmental Panel on Climate Change, next, to conclude that it is extremely likely that human influence has been the dominant cause of the observed warming since the mid-20th century. Now, you'll often hear contrarian politicians who want to sound like they're on the side of the science. They don't want to sound like they're climate change deniers. So they'll say something like, well, human activity has some role. There's probably some role of human activity. Well, actually, human activity has more than 100% of the role in the observed warming we've seen, because we actually overcame a small natural cooling trend. So we're responsible for all of the warming that we've seen. And that's the conclusion, again, of the world scientists as reflected in the reports of the Intergovernmental Panel on Climate Change, the IPCC. Next. Next. So we also know that the recent warming is unprecedented as far back as we can extend estimates of temperature. Thermometers only go back about a century, so we use so-called proxy records like tree rings and corals and ice cores to extend the record back in time. And what we find is that there is no precedent as far back as we're able to go, more than 1,000 years, for the warming we've seen. Next. Now, this is a curve that was published by me and my co-authors back in the late 1990s. It got to be known as, next, the hockey stick curve. And it became sort of this iconic graph in the climate change debate. And it became a focal point for climate change contrarians who thought they could just discredit this iconic graph, then they could claim to have discredited the entire case for concern about human-caused climate change. Now, obviously, that's absurd because we've already seen how fundamental the evidence is, that the planet is warming and that we can't explain it by natural factors. With or without the hockey stick, we would still be very certain in that conclusion. But the hockey stick did sort of tell this fairly compelling story, right? You don't have to understand the complex workings of Earth's climate system to understand what this graph is telling us, that there really is something unprecedented about the warming we've seen today, and by implication, it probably has to do with human activity next. And so the hockey stick has been attacked by the climate change contrarians, climate change deniers looking to discredit this and to claim by doing so to discredit, again, the entire case for human-caused climate change. But there's a veritable hockey league. There are many of these reconstructions that have been done by different groups using different data, different methods. They all come to the same conclusion that the recent warming really does appear to be unprecedented as far back as we can go, even farther now, at least the past 1,300 years and probably longer than that. Next. Next. And that's the sort of evidence, next, that has led the IPCC, next, to conclude that with a high degree of certainty that the recent warming really is unprecedented as far back as we can go. We are engaged in this unprecedented experiment with the one planet, again, that we know that supports life. Next. I've talked about my experiences in the center, sort of in the arena, the public arena of climate change over the years, and how I've come to embrace the role that that's afforded me to inform this very important conversation about what is arguably the greatest threat that we face as a civilization. It's not what I signed up for when I decided to double major in applied math and physics at UC Berkeley as an undergraduate and go off to do theoretical physics. I didn't think that I was sort of on a career trajectory to find myself embroiled in one of the most contentious political debates that we've ever had. But it is where I found myself because of the scientific work that we've published. And I've embraced, again, the role that's provided me, the opportunity it's provided me to inform this very important conversation. And I talk about that in my book, The Hockey Stick and the Climate Wars. All right, so what about the future? What about, what's in store? What's in our future? Next. Well, that depends very much on us. Next. If we were to act, if we were to engage in an earnest effort to transition rapidly away from fossil fuel burning towards renewable energy, we can still keep warming below that often quoted dangerous level of planetary warming of 2 degrees Celsius, 3.5 Fahrenheit. We can still do that. On the other hand, next, we continue with business as usual, or higher than that, next. Higher than that, next. And next. Somewhere between 4 to 5 degrees warming of the planet, Celsius, that's 7 to 9 Fahrenheit warming of the planet, if we don't act on this problem by the end of the century. Next. We actually have to come down and do this one. Here we're watching an actual climate model as we go on into the 1970s, going quite slowly. And we're seeing individual years, and we see how dynamic these climate models are. They really simulate the dynamic nature of ocean currents and atmospheric currents. But certain things start to emerge. Now we're getting into the future. We still have cold winters. A snowball in Washington, D.C. doesn't disprove global warming, Senator IGIHOF. We'll still have cold winters, but they'll get fewer and farther between. You see the El Nino events in the tropical Pacific. You see the warming and cooling that comes and goes. These models reproduce quite realistically now the El Nino phenomenon. There are lots of reasons to take these models seriously. You can see the Arctic amplification, how much more warming there is in the Arctic as ice melts and sea ice disappears. And there's one interesting anomaly you may be noticing in the North Atlantic south of Greenland. Is it a glitch in the model, or is it something real? It's actually something real, and we'll come to that in a moment. Next. So Arctic sea ice. The critics will sometimes tell you these climate scientists like me, we're alarmists. We're overly, we're overstating the implications of the science. We're presenting alarmist scenarios. Historically, if anything, the climate science community has been overly conservative. What we're seeing is that many of the changes we are now witnessing are playing out earlier and with greater amplitude than we predicted. And one example is Arctic sea ice. You can see that shaded purple region is what the climate models project for the future. The red curve is what's actually happening. We're outside of that range. We are seeing lower levels of sea ice in the Arctic at the end of the summer, like right now, than the climate models say we should be seeing. The climate models say there will be Arctic sea ice most likely until the end of this century. The observations seem to be saying we're on a trend line of seeing an ice-free Arctic in a matter of a decade or two, faster than the models suggested. And that has implications for sort of the remarkable biota and ecosystems of the Arctic, the polar bear, the walrus. We're talking about a fundamental threat to this unique ecosystem on our planet. Next. Now, another example of where things are playing out faster than we had predicted is in the melting of the ice sheets. Now, when sea ice melts, it doesn't raise global sea level because the ice is already floating on the ocean. When land ice melts and runs off to the ocean, that raises global sea levels. Now, the models said that we shouldn't see the Greenland ice sheet and the West Antarctic ice sheet, the part that's most susceptible to warming and melting. The models, a decade ago, said that we shouldn't see that until mid-century, later this century. We're seeing it already. We're already seeing these ice sheets melting, losing ice at an accelerated rate, and contributing to sea level rise earlier than we thought they would. And this is an example of what we sometimes call a tipping point phenomenon. Once you set this in motion, once you destabilize the ice shelves that help prop up the ice sheets, then you begin a series of processes that can't be stopped. Even if you could somehow cool the planet back down, you wouldn't be able to stop it. Next. And again, we are seeing these ice sheets lose ice earlier than we expected, contributing to sea level earlier than we expected. There is uncertainty. There is uncertainty about the science. And again, the critics like to say, well, there's uncertainty. Uncertainty hasn't been our friend. As we learn more, as we discover more, as the models become more refined, we're learning, once again, that things are more dynamic, that things can happen faster than we thought. Next. Next. This is an example, as I said, of a tipping point phenomenon. Once you set it in motion, you can't stop it. There are other examples. Next. Anyone see the movie The Day After Tomorrow? It wasn't a great movie. I show it to my class because it's fun to talk about the science in the movie, and much of it, of course, is unrealistic. It's sort of a caricature of the science, but there is at least a grain of truth to The Day After Tomorrow. By the way, you can see there's Dennis Quaid, and he's speaking to an international group of politicians. The conveyor belt ocean circulation pattern associated with the warm current, the North Atlantic drift that brings warm water up to Greenland, to Europe, Northern Europe. We sometimes call that the conveyor belt, or the meridional overturning ocean circulation. It's going in the wrong direction in the movie on that screen in the back. But this is associated with the warm currents that move northward in the North Atlantic, warming the North Atlantic and neighboring regions relative to what they would otherwise be without that current. And then it sinks in the Arctic. And then it returns at depth and forms this ribbon-like global current system called the conveyor belt. Now, that sinking in the North Atlantic is driven by the density of the water, and the water is dense because